Hi, welcome everybody to the first official workshop of the Encode Summer Hackathon sponsored by the Solana Foundation. It's so nice to see you in such wonderful numbers and so beautiful to see so many people returning from yesterday. Today we are joined by Jacob from the Solana Foundation, who will provide you with an intro to building on Solana. If you have any kind of questions, I think you can pop them in the chat, and Jacob will probably answer them at the end or along the during the workshops, whatever he finds best. Jacob, feel free to pop it off whenever you are ready.
All right, let's see if I can get everything to work the first time.
Yeah,
All right, perfect.
and that's it.
Let me get rid of all distractions and we'll get started. All right, so today I'm kind of here to talk about how Solana works and gig them to the DGen in the chat. So kind of want to chat about like how Solana works, how does the consensus work on Solana, and then do a quick deep dive on everything that you need to get started building on Solana, like all the different building blocks that you need to understand what you'll run into when you start building on Solana. So let's first go through like the general technical advantages that you'll find on Solana. So first, what you'll often find and what you'll often see whenever you're working with Solana is that we have incredibly fast confirmation times. These are about 400 milliseconds every slot. And each slot, there's about 4,000 average TPS that happen every single slot. So 4,000 TPS, 400 millisecond slots, incredibly fast to get your transactions through. The second thing that you'll notice when you're developing on Solana or building on Solana is that there's incredibly low transaction fees. So these are sub-cent level transaction fees. They allow you to be able to make transactions and actions on the network without really even noticing that you're using any money for gas. So this is another great advantage that Solana has on other networks. And all of this is while maintaining a consensus across 2,500 validators. The Nakamoto coefficient, which is used to measure decentralization, is the highest out of any blockchain out there. It is really novel how Solana is able to achieve both fast confirmation time and low transaction fees while being one of the most decentralized networks in blockchain. So let's go through like a quick network overview on how it creates blocks and processes transactions. So first off, with Solana uses proof of stake. And with most proof of stake networks, you have a leader that is creating the blocks. And so what you have happen is transactions are sent by users to the leader via the cluster. Those transactions are then verified to be correct and packaged into blocks. Every leader in Solana has 4 consecutive slots, at least if they have enough stake on the network. Then once those blocks are packaged and those transactions are ready, they're distributed to the other validators. Now, one quick thing I want to note on the distribution of transactions and blocks to the other validators is that this is done via something called Turbine. So Turbine is basically kind of a gossip protocol or a distribution of message protocol. This is incredibly fast and something different than you see in most networks. So in most networks, if you have a ton of different validators on the network, say you have 2,500 plus, like Solana, and you want to distribute the messages as fast as possible to all those validators, how would you actually accomplish this? Most networks, they do a variety of different things, but they go one on each. Or if you take, for example, Ethereum, they're pulling from a mempool and then they're sending the blocks out to everybody. This is not exactly how Solana works. Solana does not have a mempool, and they just send transactions from leader to leader. And then with Turbine, they're sending the transactions or the completed blocks in kind of like a fan out pattern. So you have these neighbors, and they fan out into kind of like a tree. This makes it to where you don't have that many hops or transfers between the leader and validators on the network in order to get to all validators on the network with the correct transactions. So whenever, another thing to note, and this kind of goes into previously how Solana achieves such fast confirmation times, is that when a transaction is executed on the network, it's executed in parallel with other transactions within the same block. And even not just within the same block, there's kind of like subsections in this block called entries. So you could have parallel transactions within subsections of each block. So this is very different than, say, Ethereum today, where Ethereum is single-threaded. Basically, you execute a transaction, then you wait, then you execute the next transaction, wait, continue on to each transaction throughout the network. Solana does this all within parallel, based off of whether or not the transactions execute based off the same accounts. For example, if Jacob, am sending money to my colleague Joe, and then my colleague Colin is sending also money to my colleague Jonas, those transactions will run in parallel. But if we were both sending money to Joe, those would have to wait for each other to finish to execute the next transaction. So that's general overview of how that works. And then something to note, and what you often see whenever you talk about Solana, is something called proof of history. So this is not a consensus mechanism, but it's a clock before consensus. So all of this stuff is happening to where we're sending transactions to the leader. The leaders are verifying and packaging blocks, sending to everybody on the network. They're executing transactions in parallel, but there's still the point, and what you find in most blockchains, that you need to be able to align together on how long all this process should take, roughly, so that one leader does not get ahead of the other. There's not like skip slots where blocks are not created. Transactions are correctly packaged, and also one leader can't hold up the entire network. So proof of history is kind of just like a hashing algorithm that aligns the whole network, that each time I package a block, it'll take roughly 400 milliseconds before the next block. And if I exceed that threshold by X amount, go ahead with the next block. Don't wait for me. I've lost my turn. This guarantees that everybody's synced up, everybody understands exactly which leader it should be next, and make sure that also no leader is single-handedly going to slow down the network. Another thing I kind of wanted to bring up that's special about Solana is something called localized fee markets. So this kind of is it's a product of having those parallel transactions. So if you take, for example, Ethereum, where I said was single-threaded, we see Ethereum whenever you have something like a large mint on Ethereum. Like, for example, if you had like the Bored Apes mint, that basically cranked up the fees massively on Ethereum and made the network unusable to most people out there. And that's not really what you want to do if you want to create a consumer level application. So instead, because of Solana having parallel fees, what you can have is hotspots. So say there was the Bored Ape mint on Solana, and it was being highly used and tons of people were going after it. That one mint won't affect, say, I sending money to Joe anymore. The reason being is it's localized to that specific mint versus everybody else's on the network. So people that are waiting in line for that mint, they will pay more in order to get better priority against that specific mint. However, everybody else that's working on any other application won't be affected by the large amount of people fighting for that mint. So it's really cool, and this is a very special optimization that Solana has that enables consumer level applications to always have low fees on the network. So takeaways: fast confirmation times, low transaction fees, no mempool, executes everything in parallel, and ideal for consumer level high performance applications. All right, so let's jump into programming concepts on Solana. So as you may be building during the Encode Hackathon, you want to know, how can I actually build on Solana? How can I make those smart contracts or programs on Solana? And how do I interact with the chain? So let's first go into the concept of an account that I mentioned briefly. An account is basically like a slice of data on the blockchain. And what you'll find everybody talking about is everything is an account. A program's account, a wallet is an account. Their transactions are interacting with accounts. Everything that you're working with on the Solana network is considered an account. And these are some properties of the accounts. They hold their unique 256-bit addresses. So it's like every account I can find it via an address. They hold some balance of SOL within like Lamports, which is the smaller value of SOL, can store any arbitrary data. You could say hi in it or something like that. And data storage is paid with a concept called rent. Pardon me. So rent is kind of like your payment for storage. Now note, even though it's called rent, it might be more of a deposit because you can get this back when you close the account and you don't actually lose any of this amount over time. Anyone can credit SOL or read data. So anyone can send SOL to a different account or read the data on the network. So just as a note, data storage, it's not private. It's available to everyone. It's permissionless, but only the account's owner can debit SOL or modify the data. So if I have the wallet, my wallet is an account. Only me, who controls the wallet, can update the SOL balance to pull it out of that account or modify the data on that specific account. This is kind of like what you would have at the very least amount on an account. This is the key is considered the address, so how you find the account. Lamports is how much the account currently holds. This can be for rent or just the balance that it holds at this time. Data is just whatever data that's stored. Executable tells you whether or not this account is a program or smart contract or just some rather random data account. And then finally, who has right access to the specific account. All right, so let's talk about programs, or more commonly known in the blockchain industry as smart contracts. They are special kinds of accounts. Data is what's considered as eBBF bytecode. It's written in Rust, C++, C, and Python. There are some initiatives that allow you to write programs in other different languages such as TypeScript and Golang and even Move. What's cool about Solana is it's not tied down to one specific language. You can write in many languages. There just needs compiler support for it. It's unlike say Ethereum or EVM, which requires things to compile down to Solidity in order to execute those smart contracts. This one, as long as they compile it down to LLVM bytecode, which is a standard that a lot of languages use, like Rust, C++, you can execute your smart contracts on Solana. One thing to note is that programs are stateless. Let's think about Solana as like it's a more functional programming paradigm rather than object-oriented programming. You use those programs to execute basically on other data. So you'll take a program or a smart contract and you'll send it accounts that give you the data for the program to execute. And then all those programs execute within parallel. In order to modify those specific accounts, you must be the owner. Programs have specifically inside them instructions that you can call upon to execute. These are like function calls. And then programs can interact with other instructions of other programs. This is what's called like cross-program unification. So takeaways of that part: everything is an account. All accounts hold SOL. Accounts can store any type of data. Accounts can also store executable programs, and accounts are passed into programs allowing for parallel execution. I'm going to pause right there because I think I see some questions. So what does Solana choose 9 decimal places for LAN ports as opposed to 18 decimals we have in EVM? Was the rationale behind the choice? So 9 decimal points. So every balance is a U64. And a U64, gosh, I don't remember the max. But if you have 18 decimals, you are limited based off of the max U64. So let's take a quick look into that. So a U64 max. Let's just improv looking it up. So U64 max, the largest value is this, right? So 18 decimals, 6, 9. Yeah. So basically, that's your 18 decimals, and you would have 2 values, or basically under 100 total SOL cap. So what does this mean? Under the hood, all tokens on Solana are represented via U64 values, and the decimal places just tell you where to put that decimal for making it pretty in UI. And I'll get to this later in the presentation, but just to answer this question, if you had 18 decimals, your max supply could only be 18. So because of the U64 max, because you'd put the dot right there, and then you would max out on 18.446, etc. With 9 decimals, you'd put the dot right there, and you'd max out at, what is this, 18,444,000,000, whatever. So that's a quick aside into that, answering that question. All right, let's go ahead and continue. This will come up again later in the presentation. I'll just gloss over it since we already talked about it. But let's go into transactions. So a transaction is basically anytime you want to create a set of actions on the network. You send a transaction to an RPC client, and that RPC client then forwards that transaction to the cluster. RPC clients are not necessarily running on the network. They interact on Gossip by getting information from Gossip, but they're not verifying. They are verifying transactions, but they're not verifying against the cluster. So if you are sending to an RPC client, just like you do on Ethereum, you're kind of trusting that RPC client to send to the cluster, and the cluster will manage it itself and verify, execute, etc. A transaction can be seen as this format. So you have a list of instructions. Instructions are actions that you can take on Solana. You have a recent block hash. So a recent block hash is for kind of like deduplication and also the expiration of transactions. What does this mean? Take, for example, on EVM. If you make a transaction on EVM or make a signature, you sign with your nonce value. And as long as that nonce value is still valid, you can still make those transactions. And what this causes is, if someone signs a transaction, sends it to some server, and that server holds it for, I don't know, 20 days or something, and then executes it and drains all the funds from that wallet, you're just out of luck. So recent block hashes, what's cool is that your transaction is only valid for 150 block hashes after the transaction was signed. So that's a very small amount of time. 150 times 400, that's like 8 minutes or something like that. meaning that someone can't just execute your transaction later based off your signature. This is also used to where if you're sending transactions, a ton of transactions on the network, and you accidentally use the same instructions and the same recent block hash, it'll dedupe it and continue. So you can't just spam the network. The fee pair on the transaction is specifying who's paying for this action, and then the signers are all the signers are required in order to execute this transaction. So say I am signing for as a fee payer for this transaction, I'd be included as a signer. However, I can also have someone else, say Joe, my colleague, sign for my transaction and be the fee payer. But if it does debit my account, I would still have to sign it. So we can both sign it, but he could pay. All right, so some takeaways is programs are invoked by instructions. Instructions are sent via transactions. Transactions are atomic and transactions must be signed. So transactions are atomic is something I didn't touch upon. Let's touch upon it real quick. If any instruction within a transaction fails, the whole transaction is rolled back. This makes it really awesome for like financial applications to where you're running multiple instructions off of smart contracts within Solana. And if any of them fail or they have reentrancy issues or something like that, the whole transaction fails and you don't lose whatever actions you were placing up until that transaction. All of them will fail. So it's really nice to have and especially good for financial applications. All right, let's talk about custom data that is associated with programs. So let's first briefly revisit account ownership or how a program can own an account, as we mentioned earlier. So if you kind of look at how Web 2 applications read and write from a database, it must have access, it must have like the credentials, it must know that it's endpoint. Oftentimes when a Web 2 application is interacting with the database, you kind of have like a layer in between from the front end. So you have a front end, you have a layer in between with all the access that's kind of closed off on what it can do, and then it connects to the database. So it's very permissioned. It's very owned. It takes a lot of credentials to update the database. But you don't really have that in blockchain. So on Solana, we use account ownerships to assign different accounts that have data into them as owner or who their owner is. So you can make a program, an owner of a bunch of accounts that can do very similar to what this Web 2 application was doing. This program can write data to these accounts, but people, say me or you, who don't have ownership of these accounts cannot write or update the data within the accounts. Kind of to explain this further, you kind of have to know the concept of what's considered program-derived addresses or PDAs. So whenever you're creating an account that is owned by a smart contract, you use program-derived addresses and you assign the program ID that is typically the owner of that account. Use some seeds, and these are basically like keys to find the address. So you kind of see as these two, the seeds and the program ID as the key, and the value being what's at the address. One other feature of a PDA is that a program can sign for the sign for that specific PDA. So for example, token accounts are PDAs, and you have to have the ability to sign transactions to update the token account balances, to transfer tokens in and out of a token account. You can do this with a program and using PDAs. If you have a transaction, so if you have a PDA and you're trying to send a transaction without signing the program, the signature will be required to be created using the seeds from within the actual program. And one of the seeds is the program ID. So we know that the program could only be the one who executes the signatures. So let's kind of like dive more into PDAs because they're a big deal on Solana, and if you want to do well within like Solana development, you really need to know them. And usually, when you're creating accounts, if you're not using PDAs, you kind of have to question why you're not doing that and dive into that. So let's kind of like really dive into this real quick. So if you take like a table profile and say we have columns address, username, and email, and the seeds or the lookup that you're using is username, is profile and wallet address. So you're looking up these username and emails, and you can find the addresses, right? The same thing is that if you're looking at a table of profile addresses and post counts, um, you can use the seeds of post, the wallet address, and the profile address in order to get that post count. So these are kind of like the key value pairs in order to get the data you want on chain. So takeaways, account addresses can be derived from seeds, and that's where how you create PDAs. PDAs can be used to relate data across accounts, and PDAs don't have private keys, but the programs can sign for them if they own them. All right, so let's tie it all together. So here we have a program that, say, operates on an account with a count variable that you can maybe increment. So this is an instruction. It's very pseudocode that's just incrementing the count, and our data is count. What you'll have is you'll have some DApp, right, hosted on some normal Web 2 application. Whenever you're sending transactions to update the network, you would send them from that client to the RPC client. The RPC client would forward that transaction to the latest validator or leader. That instruction for our program on the on-chain is executed via that transaction, and the counter account would have the count modified. So you can see there, just went from 0 to 1. So we incremented it. Good job. That is the full flow of basically a transaction executing and sending over the network. So some quick takeaways. Applications send transactions via RPC. RPC forwards transactions to the network. Validators then execute those transactions, which invoke programs, and programs update account state. All right, so let's quickly go into the fundamentals of tokens, of how they look on Solana and how they're different from EVM, and how you kind of interact with them. So similar to Ethereum, Solana has a token standard for any tokens on its network, and this token standard is called SBL token. However, this standard kind of operates quite differently than Ethereum. The biggest difference is that Solana uses a single program versus many programs deployed, meaning that if you have a token program and want to create a new token, you don't have to deploy another program or a smart contract onto the network in order to get your token. So in EVM, if you wanted to have another ERC20 token, you would have to deploy another smart contract. On Solana, you would just use the currently existing token program in order to deploy a new token. So let's get into what that looks like. The token program, what it would do is whenever you try to create a new token, you would create what's considered a mint. And the mint is an account owned by the token program that represents the token. That has the values of like how many there are, what's the total supply, and what kind of things you can do with it, and who is the mint authority or who can make more tokens. You have something called the associated token program, which then keeps track of the balances for different wallets. So say I have a token account of this specific mint. Say this mint is, I don't know, we're going to just call it basketball token or something. This is basketball token, and I have 5 basketball tokens. My balance is contained within my associated token account, which is a PDA with my wallet and the associated token program. This is all related back to the mint. Now we have the balances, but how do we get the actual logos and stuff? This is done via a metadata account, which is built off of the metadata program on Solana. So this metadata account can have things like logo, information about like what the name is, etc., to showcase what this mint and how much I have are in my wallet. All right, so if you kind of like look at the instructions that are used in order to create the token and get tokens into my account, you would have multiple instructions in a single transaction. You would need to create those new accounts, initialize that account as a mint. You would have to create that token account and then mint new tokens to my associated token account. That way I have tokens and I've created the mint and I have some amount. So big takeaways, remember you do not have to deploy a new token program to create a new token. You just create new tokens using RPC calls. And then you can use the metadata program to create a metadata account to describe what the token is. So actually minting that SPL token, you create an account for the mint, you initialize that account as a mint, you add any metadata to it, the wallet will then create an associated token account, and you mint tokens to that associated token account. So let's look at what that looks like in practice. Creating this funny looking dog token. You have that mint, initialize the account as a mint. You give our token that icon that we had previously, and now we have a token. So this is everything that you have to do to create the initial token. But now we want to get it into Nick Gill's and John's wallet. We create their token accounts, and we can mint them some tokens, say 100 each of the same mint. So now they have tokens, they have this funny looking dog token, and they're good to go. So some quick takeaways is a mint must be created and initialized before it can be minted to someone. An associated token account is required to mint to someone's wallet. There's something called Token 22 that we'll touch on really briefly now. Is it introduces new features for SPL token. This is another token standard that gives you some extensions on the current SPL token. So SPL token, you can freeze, you can mint, you can transfer. Token 22 allows you to have like fee upon transfer or confidential transfer or interest bearing token accounts. These are all additional features that you can have that expand what the original SPL token does. All right, let's go dive into NFTs real quick. So NFTs on Solana are SPL tokens. They have 0 decimal places. They have a total supply of 1, but they have highly customizable metadata. So they use the metadata program in order to create what's considered a master edition and associate with a full collection. So you're basically using multiple programs to associate that this token is an NFT. So quick takeaways, 0 decimal places, supply of 1, NFT metadata, you can basically make it anything you want. Account state for SPL tokens. Now that we've covered all the fundamental, let's go into account state, into actual deep dive what it looks like. So if you look at the metadata account, this is a PDA. It's off of the metadata program in the mint address with the seed of the string metadata. This has the data of who can update it, what collection that NFT belongs to, and then what is the actual data that you expect. The creators array here is kind of used to distribute royalties. That gives more information on like NFTs. And I think that's just about it. So I'll take any questions that people have on Solana. And if you need to reach me, you can find me at Jacob V. Creech on Twitter or Jacob Creech on Telegram. But yeah, happy to help anybody and take any questions.
Yeah, thanks, Jacob, for the wonderful presentation. I think really it was a great overview of what Solana is and how to start with Solana. Yeah, guys, just like Jacob said, if you have any questions, which I see some people are typing in the chat, feel free to pop them and Jacob will answer them. Um, Before any questions come up, I have a question actually. To go back to the very beginning, you mentioned that it's possible to deploy smart contract on Solana with some other languages like TypeScript or Golang, I think. Could you go into some, if what kind of frameworks, or I guess what kind of infrastructure exists already for deploying those kinds of contracts with different languages that are not
Okay.
Rust or C++? plus plus?
Sure. So Rust is like the main one that has the biggest support today. It's deployed via a framework called Anchor. So you use the Anchor framework to create smart contracts on Solana with Rust. There's also what's considered native, which is it's not. It's basically like you instead of having React, you just have TypeScript or something. Native is Rust, C, C++. So those are covering those three. Uh, Python is deployed via a framework called Seahorse. This is what you can use to build basically Python contracts if you don't want to learn Rust. And it works. It's not like fully audited today, but people can do it today. And it's really cool that people like can just write Python. So Golang is currently under development. It is using something called GoScript as a kind of like under the hood compiler. Um, so the Golang is done via a framework called Golana. TypeScript is being built out by the team over at Ironforge. It's not publicly accessible today, but at some point will be soon. Move finally is being built as a native addition to the basically to Solana in general. It's being built by labs. That should be out later this year, but also not, you can't build it today. I can
Yeah,
quickly
yeah.
add all those as links.
Yeah, feel free to do so. Yeah, would you say in general that having so many frameworks for so many different languages is generally an advantage for the Solana blockchain, as opposed to some other blockchains that are currently live?
Right. It's definitely an advantage. And given that we're building all the support for basically hitting the majority of developers, we'll get a lot more over time than saying tying yourself to Solidity, which causes a lot of issues. Especially what's great about Solana is that given that we use basically a lot of the mainstream languages out there, like Python or Rust, you building on Solana is a transferable skill to not just any blockchain, but outside of blockchain too. So that's something that I find like as a big plus, because if you're building with Solidity, you're stuck there, and you basically how to build on EVM. Can't use that anywhere else though. Nowhere else in the industry can use that. It's not transferable. You're stuck there, and it's not great.
Yeah, yeah, exactly. Plus, I think that this will be very much useful to all the people building projects for this hackathon, because it will like people won't necessarily have to go into the Solana blockchain through one entry point, but will have all these options to take. We have a couple of questions that have come in the last couple of minutes. Augustine is asking, Solana NFTs do not support standards like ERC 1155, correct?
I'm going to have to look up 1155, but I believe they do by default. Here's the 1155. So it's a multi-token standard. Let's see, what is the simple summary? Multiple token manage single make contain. Yes, they could do this. You could have multiple token types within a single token. You can also, so there's a lot of different things, and this is kind of a common misconception between EVM and Solana, is that we have a bunch of these different ERC standards, and most of them by default are enabled on Solana. You just have to, there's just like you have to figure out how to do it. And like, for example, the multi-token standard, totally possible. ERC 721 is also totally possible. Account abstraction, which is a very popular ERC, been possible for like 2.5 years on Solana, basically since you could call other programs. Having tokens own other tokens, also already possible on Solana, has been for a year and a half. Um, it's it's more of like you just have to do the look into what it is and how you do it on Solana. We will be coming up with these pages to explain exactly how you do each ERC that has majority adoption on Solana soon, but it's not out just yet. It might come out during this hackathon though. So I'll definitely announce it and let y'all know if it does.
Yeah, absolutely. Like, if anything happens on that front, feel free to uh, contact me, and I'll let everybody know about the update. So I hope this answers your question, Augustine. If you guys have any more, yeah, actually, Augustine is following up with another question. Must we use Anchor framework to actually write Solana programs, or can we do it directly from Rust?
You can do it directly in Rust. There's something called native, and you can choose to do it directly in Rust, and it doesn't have any other issues. So I'm going to post right now into the chat something from. There's a bunch of program examples in this repository. These program examples both give Rust, native Rust, Anchor, as well as oftentimes the Python with Seahorse. So you can kind of compare and contrast of like, okay, if I want to do this specific thing with Rust, this is how I do it versus Anchor versus Seahorse. Another big, great example that y'all should know in general is the Solana Cookbook. Solana Cookbook, for whenever you're interacting with anything on chain, it'll give you a ton of examples with different languages. So it'll have both program examples as well as client-side examples. There's a lot more languages available on client side versus just Rust, basically. Dejan asked, is JavaScript needed or can I use only Rust? You can use only Rust. There is something called Oxylana, I believe. Let me look it up real quick. And what they do is they're allowing you to do full stack development within Rust. So you can make the front end with Rust if you really want to. If you're like hardcore Rust engineer, that's an option that you can have.
Yeah, awesome. Any more questions, guys? Yeah, if not, I think we can wrap it up. Yeah, thanks, Jacob, for all the wonderful presentation, first of all, and for all the useful links. I'm very sure that people will take them and build something out of them.
Awesome.
Yeah, one more thing to note, guys. A reminder that all the relevant information about the hackathon will be or already is in the Hacker Pack on Notion. There you'll find all the workshops, the workshop recordings, the workshop schedule, the bounty prizes, the bounty information, sponsor information, resources. All these links that Jacob just posted will be made available over there as well. Yeah, thank you, Jacob, and thank you everybody for coming. And tomorrow we're continuing the workshops with Intro to Solana Pay, also by the Solana Foundation. See you guys tomorrow.
Awesome. Thank you.
Have a nice day. Bye.